So from this video we'll be starting a new series of Rust programming language. So Rust is a programming language predominantly made or designed for systems programming, and currently many other, you could say, frameworks or libraries are developed around it, and it has made its way into the Linux kernel as well. So we'll get started with Rust, and the main core feature, or you could say the core goal of Rust, is safety. Okay, so over the series we'll see how Rust actually provides safety. So let's get started. So first program will be hello world. Okay, so we'll call it hello rs, and the hello world is the only simple example of Rust, I would say, because everything else slightly differs from the way we have learned programming over the years. Okay, so hello world, uh, hello world. Okay, so now to compile this thing you will need a Rust compiler. So you can simply head over to their website and you could download their compiler as well as the package manager. The package manager is called Cargo. Okay, so just like every other programming language, like Node has its Node runtime and Node package manager, so Rust also has that kind of feature. Okay, so you have to download both, because in the upcoming videos we'll be using Cargo predominantly for creating the projects, because Cargo gives us kind of a flexibility for importing different types of packages and sort of thing. So yeah, it does help. For now, for a few videos we'll be using simply Rust C. After that we'll be moving on to Cargo, so just make sure you download both. And now let's just run the example, and here it has created hello.rs, and we'll just run this thing and it will print hello world. Okay, so as I said earlier, this will be the most easiest example of Rust you would see. Okay, and after this we'll be doing a very simple example which is done in every other programming language. You could easily write that example in every other programming language, but in Rust things work a bit differently. So we'll be starting with the addition example. So this will be the final example that we see today in this video, because this is the first video, so I don't want to uh, cram up a lot of concepts so that you don't get confused. Okay, already Rust is a bit confusing language in itself if you are not from the systems domain. So for input output, so the idea of addition example is you take two numbers, you input those numbers and you calculate the sum. Okay, so usually in other programming languages this thing is easily accomplished. You just take two numbers and you make addition of those two numbers and all set and done. Okay, so you would have in some other programming language like C++, you have cin to take the input. In C you have scanf or gets and sort of things to take the input. In other programming language like Java or sort of a thing, there you have slightly different mechanism like scanner, buffer reader and sort of a thing. So here also in Rust you have a slightly different mechanism. So here the idea of variables is slightly different. Everything is immutable. So what exactly do we mean by immutable? So let's just take a simple example. Let num1 is equals to 60. Let num2 is equals to num2 is equals to 40. We all know it will be 100. Okay. Let sum is equals to num1 plus num2. Okay. And again here we'll be using our macro of print line. Okay, so one more thing, in other programming languages usually the print line is a function. In Rust it's a macro. Okay, so to get started with this thing we'll write the sum of, so these are, you could say, placeholders for the variables that we'll be using. So like you use what do you call format specifiers or sort of a thing. In C++, you don't even need that, but in C you use it. So it's somewhat analogous to that thing. Okay, So here we'll write num1, we'll write num2, and here we'll write sum. Okay, so to run this thing, let's see addition.rs. So it will show a couple of warnings for now. See here. So the first warning that it has given is you have used unused import, that is of stdio, because we have not yet used stdio. So you can simply comment this out and get rid of that warning as well. Okay, because Rust is careful about all the things. So sorry, addition. See here. So now it gave away the output. But now what if I change the value of num1 to 20? Let's see if Rust can do that thing. Oh, you cannot, because cannot assign twice to an immutable variable. Okay, so this I guess you all must have known. But what if I write let over here again? Does it work or not? See here, it will just give me a warning. See, it has just given me a warning. Previously it was an error, you cannot assign. Okay, so now if I run this thing with obviously a warning, 20 plus 40 is 60. Okay, so here what I have done is I can not reassign, but I can redeclare a variable in Rust. Okay, so this is an important concept over here which will come into play in a few minutes. Okay, so here what if I want to change the value of this thing? So let's just make it mutable by saying mut. Okay, and recompile this thing again. Like we have overwritten that thing, so it is giving an error. Sorry, a warning. See here, it is doing it for this thing. So it has said that you can suppress the warnings using this, what you call the pragmatic expression for warn unused arguments. Okay, so it will show a couple of errors unless you have written you could say annotation sort of a thing for this thing, for stopping certain errors or warnings. Okay, so this is a simple example. So now what if you want to take a user input on this thing? So like the first step would be making both these things mutable. Okay, and secondly, even if you make them mutable, you cannot directly take the value into a number. Okay, so first we need to do string new. Okay, so let's just first do a print line, enter first number. Okay, and first it is assigned to a string. Okay, watch carefully what we have done over here. So now we are taking input in a string. So here we write io stdin. Okay, so after that you write read line, read underscore line. Okay, and again once again you write ampersand mut and num1. So now you are actually taking the value into num1. But again, as I said earlier, Rust is very careful about the safety. So you have something called as expect. Okay, so here expect runs when you cannot take an input. Okay, so if any kind of exception occurs, so it will give you this kind of exception. So it is kind of a try catch mechanism which you might have used in some other programming languages sort of thing. Okay, so now the value that has been taken from the user is inside this num1. But now if you see carefully here, it is a string. So to perform mathematical operation, you need to convert it into a number. So what we will do here is, as we done earlier, we will redeclare num1. But here what we will do differently is, now we will declare it as a signed 32-bit integer. Okay, so about the types of data types in Rust that we'll see in some other video. For now, you consider that in Rust you have variable sized, you could say, integers, floats, or sort of a thing. So you have like I32 is a signed integer, U32 is an unsigned integer. So integer ranges uh, will be different for both these variables. Okay, so you have that kind of a concept. So that is why I'm asking you that for now just assume that this is a 32-bit variable, 32-bit integer, of course a signed one. Okay, and now what we'll do is num1 dot trim dot parse. Okay, we need to trim the variable first. Okay, and after that we are parsing, where again we could get an exception which is, you could say, caught by expect. Here it could be like you have given some invalid input. Okay, so it protects, you could say, at every juncture for this thing. So now what happens if you remove the string? So usually what happens is when you take input in Rust, it takes the carriage return and the new line, you could say, escape sequences along with it, along with the value, that is the actual value that you have typed. It takes the carriage return and new line sequences with it. So you need to use the trim function to remove those things. Okay, so if you don't remove those things, then you will have invalid input error. Okay, so as we did for num1, similarly we'll do the same thing for num2. Okay, so let's just copy this thing and do a, okay, just make sure you don't mess up. And here we'll replace num1 by num2, and here num2 dot trim. If you see that we have reassigned the values, or you could say redeclared, not reassigned, redeclared those values. Okay, so this is how you take input in Rust. Okay, and if you run this thing, okay, hopefully there won't be any errors or warnings. Let's just see. No, it has some errors and warnings. Surprise, surprise. Okay, so we had commented stdio, std colon io. Okay, what they're saying, remove mut. Okay, yeah, we could remove this thing. Yeah. The second part, after you have already made it mutable, we can remove it. Okay, because now we are doing the operation. Yeah, so like we removed those two warnings as well. They were warnings only. Okay, you can keep it mutable if you think that you need to change those values across the course of program, then you can keep it mutable. Okay, there are cases where you need that kind of support. So let's just run this thing. Okay, so enter first number we have written, so like we have not written enter second number, sorry. So let's just copy this thing and paste it here. Enter second number, and okay, again we'll compile this thing and addition. So first number is 10, second number is 20. Okay, sum of 10 and 20 is 30. So we are taking a safe bet with the numbers 10 and 20 because we don't know how to compute sum of higher numbers maybe. Yeah. So this is how you write a simple, you could say, code for addition of two numbers. So by now you must have understood the Rust works on a very different level of, you could say, safety, and you could say a slightly different philosophy sort of a thing. So in the next upcoming videos, we'll first understand how and why this kind of philosophy exists in Rust. Okay, so the idea of understanding Rust is to identify what problems were there in C++ that Rust solves, or rather the cases wherein C++ sort of gives you a jump over the cliff sort of a situation where Rust gives you a safety sort of a thing. Okay, So hopefully this will be an interesting series to complete. Okay, thank you.